And hello, everyone, and thank you for joining us today for the 2025 National Weather Service Annual Winter Partners Webinar. My name is Eric Gillott, and I am the Winter Program Lead here at the National Weather Service. I'm joined today with Winter Program Coordinator Mike Busili and John Gottschalk, the Operational Product Branch Chief from the Climate Prediction Center. These slides will be provided. This presentation is being recorded and be sent to everyone who originally registered when this webinar was going to be a live event via the email address that you originally registered with. Both the recording and the slides will also be made publicly available on our Weather Ready Nation calendar webpage listed here. These are the topics that we are going to cover today. We're going to begin with John at CPC, giving a brief overview of the winter season outlook. After the winter season outlook, Mike and I will provide an overview of the National Weather Service Winter Weather Program's planned efforts for this year, including recent improvements to both our operational and experimental products. With that, John, the floor is yours.
Okay, next slide. One more. Great. Thank you very much, Eric. I very appreciate the opportunity to speak at the webinar here today. I wanted to just initially go over some of the factors influencing the NOAA winter outlook this year. Many of them were similar to last year. As you may remember, we also had a La Nina event last winter as well. And so expectations of La Nina conditions during the winter months are certainly a considerable factor in the outlook. And this can be used with respect to composites for ENSO or weak La Nina or combined winter season years, and also statistical forecast tools that are linked to ENSO-related variables such as Equatorial Pacific SST. One additional factor we have this year is the very warm above normal ocean surface temperatures in the North Pacific that we did not have last year. We'll talk a little bit about that. And also, we tend to review anomalous snow cover and depth across the Northern Hemisphere. And this year, the stratosphere's current conditions and the phase of the quasi-biennial oscillation, or QBO, and we'll talk more about that in a second, played a role, both positive and negative long-term temperature trends, and also a plethora of dynamical model guidance from the North American Multi-Model Ensemble System, or NME, and also the Copernicus Ensemble Prediction Systems. Next slide, please. So first, looking at just ocean and atmospheric conditions in the Pacific Ocean. So first, starting here on the left, we're just to note that we are officially in a La Nina advisory. La Nina conditions are present both in the ocean and the atmosphere, and this is expected to continue through the December, January, February period this particular year into early 2026. If you take a look at the plot on the upper left, which is the ocean surface temperatures or sea surface temperatures, and those departures from normal. So blue shades indicate colder than normal ocean surface temperatures, and warmer than normal ocean temperatures are in orange and red. And if you take a look at this, you can see the La Nina event that's occurring right now across the equatorial central Pacific. It's going to be a weak event. It's going to be very similar to last year, but it's still is expected to have impacts to the U.S. and is a factor in the outlook. One thing, it's normal to have above normal SSTs in a horseshoe pattern around that area of cold SSTs, but this year we have a particularly strong above normal signature across much of the entire North Pacific. Now, these have cooled recently due to the summer storminess, storm activity, but still remain considerably above normal. This is important because some of these SSTs are in an area generally where we have upper level high pressure or ridging or blocking associated with La Nina by itself. So this may act to reinforce in some ways and even shift somewhat east some of the La Nina impacts that we typically see across North America. So that's important to keep in mind. With respect to a depth, which is the fuel for maintaining this La Nina, what's shown here is ocean temperatures from zero from the surface to 450 meters depth. And you can see this blue shades indicating a reservoir of colder than normal water down to about 150, 200 meters across much of the East Central and Eastern Pacific Basin, and even into the parts of the Central Pacific just near the date line. And so there's enough cold water to maintain this event, maybe even strengthen this event as we move forward into the December, through November and into December. Next slide, please. So with respect to the actual forecast, La Nina, as I mentioned, is favored through the December, January, February period, and those are the blue column bars on the left. But you'll notice this is going to be a relatively short duration event, whereas last year tended to be a little further into the early spring. This one looks like it will maximize, certainly with respect to the sea surface temperatures, most likely in the December, January, February period. And maybe lingering into January, February, March. But our official outlook does favor a return to ENSO neutral conditions rather quickly, peaking at over 70% likelihood by the March, April, May season on the x-axis on the plot on the left. And we are now seeing probably some of the higher values for El Nino that we have seen in a couple of years as we approach the summer months. Next slide, please. So the other factor at play this winter that's quite important is what's called the stratospheric polar vortex. Now, the polar vortex has been used many times in various capacities, but at CPC, we really want to focus on the stratospheric polar vortex. That's the official polar vortex, and which is the layer of the atmosphere above the weather layer or troposphere in which we live. And it oscillates between two phases: westerly, shown there on the left, and easterly, shown on the right. And you don't need to know all the details about this, but basically when the QBO, quasi-biennial oscillation, is in an easterly mode, which it is this winter, the stratospheric polar vortex is weaker, okay? And what that means is the potential or a likelihood of a more meridional or wavy jet stream in the polar latitudes is more likely. And when you have a slower jet stream and more wavy in pattern as opposed to just very fast around the pole, Arctic air outbreaks are more likely across either hemisphere in the northern hemisphere overall. And so that's one thing that we're watching now. So if you go to the next slide, when you combine this with La Nina events, there's a lot of information here, so I'll work through it pretty slowly. First, on the bottom right is the equatorial zonal winds, which is a measure of the quasi-biennial oscillation, or QBO. And if you look at that one arrow there, you'll see that we're in the blue areas there, which is basically easterly wind anomalies. And as I mentioned on the last slide, that's when the stratospheric polar vortex or the likelihood is weaker, and likelihood of Arctic air outbreaks somewhat elevated than normal. On the top plot is what I showed recently with the forecast and the current conditions with respect to ENSO, meaning La Nina. And so the plot on the left is basically a 2x2 plot here, which shows a combination of when we're in a westerly QBO and La Nina or El Nino, and also with an easterly QBO and El Nino, La Nina. And I want to have you focus on the lower left box, which is the one in which we have this winter. Which is La Nina conditions with an easterly QBO. And what's shown in this plot are a number of dots, basically indicating that there's a 92% of all the years in which this happened, meaning when we had a La Nina event and a easterly QBO, we had what's called a warming in the stratosphere, or sudden stratospheric warming. And when there's a warming and a sudden in the stratosphere, that can lead to persistent or potentially phases of the Arctic oscillation on the negative side. Some of you may be familiar with that climate pattern. And when that happens, there tends to be more cold air outbreaks into the continental areas. These outbreaks, however, can occur in either the eastern or the western hemisphere. So just because we have some of these conditions in place doesn't necessarily mean that we're going to see very frequent, often, and severe Arctic air outbreaks all winter long, every month, every week. They're going to be varying probably across much of the hemispheres. We've seen a number of cases like this. But what this does show is that we're more likely than not to have some of these with respect to a warming, and therefore particularly more Arctic air outbreaks to the mid-latitudes, whether it be the Western Hemisphere, where we are, or Eastern Hemisphere, Asia, and Europe. Next slide, please. So with all that in mind, the official December, January, February temperature and precipitation outlooks are shown here. We are favoring below normal temperatures from the Pacific Northwest, Washington, mainly across the northern Rockies into the northern plains and upper Midwest or upper Mississippi Valley. The pie chart there shows these maps, even though they just show one layer. It's important to know that each point in this map really has three distinct probabilities with it. So even in that shading of blue, even though the probability for below normal is just under 50%, which is almost a doubling of the climatological probability of any one of these three categories of 33%, there's still non-trivial probabilities for near normal and also for above normal. So it just is a slight tilt towards below normal temperatures. For above normal temperatures, we expect those to be confined to California, the central Great Basin, the Southwest, along the southern tier of the U.S. and up through the Southeast and along the eastern seaboard to just parts of southern New England. The greatest odds there shown by the pie chart in the Arizona area, where probabilities are approaching 60% as compared to 33% in those areas. So those are most likely, as well for southern Florida and also for the parts of the northern and western coast of Alaska, with a slight tilt towards below normal temperatures for the Alaska Panhandle. Now, you'll also notice a pretty large area of equal chances in the interior, and this is because of some of the uncertainty that I was referring to earlier with variability within the season. We saw this last year. We expect much of the same this year. High variability from every few weeks to every few weeks. You always have variability within the winter season, but we expect during weak La Nina events, we often have quite a bit of subseasonal variability that actually drives the overall seasonal temperature departures over the 3-month season for both temperature, especially, but also for precipitation as well. And speaking for precipitation, we are expecting wet conditions, enhanced likelihood for wet conditions for the northern tier of the U.S., especially the northern Rockies, as indicated by the pie chart there, of greater than almost 60% in that region, across the northern tier and also across parts of the Ohio Valley. Drier conditions are expected across the extreme southeast, Florida, extreme Gulf Coast, southern Texas, and parts of the Southwest and Southern California, with slight odds for above and below normal precipitation for the western area and also the southeast or Alaska Panhandle areas, respectively, for the state of Alaska. Next slide, please. So for just to see how this evolves, for the January, February, March period, we actually expect more of a less likelihood for warmer conditions across parts of the cone as shown there on the left, where we have favored below normal temperatures for the northern tier into the Great Lakes region. A continued large area of equal chances at this time for the interior and even into New England, with relatively marginal shifts in the probabilities, just slight tilts towards above normal temperatures in the similar areas I mentioned before. But you notice the probability or the shades are much fainter across the southern tier of the U.S. Similar pattern for Alaska. For precipitation, again, the same general theme of wet across the north and the Ohio Valley. Typically in January, February, March, the signal in the Ohio Valley is more reliable and more stronger over more of a larger area, and so that's why that area has a little bit more coverage than the December, January, February map. But also for dryness continues across the southeast and along the southern tier into parts of California. And I want to mention both these outlooks will be updated November 20th at 8:30 a.m. Next slide, please. So with respect to winter, obviously we want to talk about snowfall. Snowfall conditions over the season will not be entirely related to La Nina. They can be related to many other sort of synoptic and subseasonal variability. But I did want to show what typical La Nina events result in snowfall from departures from normal. For DJF, or December, January, February is on the left, and January, February, and March is on the right. And the main story first is that with more troughing, wetter conditions, and expected colder conditions in the Pacific Northwest, Northern California, and parts of the northern and central Rockies, as indicated by the blue and purple shades, there's actually typically a above average snowfall in these areas, very good for skiing activities and winter activities in those areas. That's both for December, January, February, and January, February, and March, as you can see. This also includes more snowfall anticipated compared to normal for parts of northern New England, northern upstate New York, and parts of the Great Lakes region, more so in JFM in that area. But one of the most important things to note also with respect to the snowfall is where snowfall is anticipated or favored to be less. And one of those main areas pretty consistently is the Mid-Atlantic region, say from Virginia to even southern New York or most of Pennsylvania in that region. There tends to be a slight uptick, marginal across the Ohio Valley, mainly for increased precipitation, as noted earlier, and also across the northern tier, especially in JFM. But other areas, for example, that typically can see ice and snow during some years across parts of the central and southern high plains, as shown there, actually receive below normal snowfall during La Nina winters. Next slide, please. And basically, the final outlook will be is the November, December, January drought outlook. This again will be updated November 20th for December, January, and February. And with the dry conditions forecast, in large part associated with La Nina, favoring potential drought development across Texas, some of the Gulf Coast states, and into the southeast. However, with some improvement and removal of drought conditions indicated by the gray and green shades in the Ohio Valley, parts of the Great Lakes region, Pacific Northwest, and also parts of the Northern Rockies. And next slide, please, to wrap up. So the first slide for take-home messages, as I mentioned, La Nina conditions have developed, and we expect those to remain in place through the winter forecast. Although expectations are for a short duration event, La Nina is still anticipated to result in impacts similar to last year. But the coverage intensity of typical La Nina impacts will be highly variable and uncertain because of some of the factors I mentioned before. We do expect, similar to last year, a very high variability, frequent subseasonal changes over the 3 months. That's likely again this year, as compared to, say, more persistent conditions like we've had in the past a number of years ago when we had a very strong El Nino event. And final slide, please, for me. This is kind of just a rundown summary of the outlook itself, so I'll go relatively quickly on this. But favoring above normal temperatures for Northwest Alaska, California, the Central Great Basin, and eastward across the Central Rockies and Southwest to the Southeast Coast and lower Mid-Atlantic. The areas for expecting or favored to see colder than normal temperatures or conditions are from the Pacific Northwest eastward to just the western part, Great Lakes, and also for Southeast Alaska. Drier than normal conditions are favored for the southern tier of the U.S., with enhanced precipitation most likely for much of the northern Conus, Ohio Valley, and western Alaska. And with La Nina, drought development is possible for areas along the southern tier from Texas into the southeast. But the good news is that there should be some improvement given the forecast and hopeful verification of the forecast for the Ohio Valley and parts of the Pacific Northwest with some drought improvement and removal. So thank you very much for your time, and I'll pass it back to you, Eric. Thank you.
Thank you very much, John, and thank you for your expertise today on the seasonal variability we should expect this year. Really appreciate it. All right. Now we're going to switch gears and give a little winter program overview for the National Weather Service here. So we get this question a lot. How does the Weather Service forecast winter weather exactly? To understand that, first you have to kind of understand how the Weather Service is organized. So the Weather Service is broken up into 122 weather forecast offices, or WFOs, spread across the Conus, Alaska, Hawaii, Puerto Rico, and also further west as well, Guam. They're geographically distributed to provide local forecast information to the public and to decision makers to support briefings to local partners just like you. They are responsible for issuing all winter-related advisories, watches, and warnings, and we'll talk about what those are exactly in a little bit here. Also, there is the Weather Prediction Center, or WPC. WPC is the primary national center for winter weather, and that's located in College Park, Maryland. They focused on the bigger picture, longer term, like days or multiple days out winter outlook information and also impact information. Now, that being said, WPC does work closely with the WFOs in order to ensure consistent messaging from the Weather Service across the board. I just want to highlight really quick what a great forecast and IDSS, Impact Decision Support Services, can do when done properly. On the left is a picture of the 2011 Atlanta snowstorm called Snowmageddon. That was an event that occurred in early January 2011. It actually hit right when people were leaving work. Resulted in over 1,200 traffic accidents. You can see the pictures there. It was pretty nasty out there. And for context, they received about a little bit more than 4 inches of snow this particular event. Now on the right is this past year's 2025 Atlanta snowstorm, also occurred in early January. There was a lot more IDSS. That's something that Weather Service has really focused on in the last 10, 15 years. A lot of IDSS leading up to this event. And it resulted in much more limited impacts over the city and its people as well. For context, about 2 inches of snow fell for this event. We at the Weather Service, we really strive to communicate with emergency managers and local officials to ensure that the forecast is consumed by as many decision makers as possible. So now we're going to talk about some of the operational winter products here at the Weather Service. Before we do that, let's just talk about what we call the winter weather product cascade. So you can see on the left side of this diagram here, we have things that are further out in time, 3 to 7 days prior specifically. Tends to be products that have outlook in the name and focused primarily created by the Weather Prediction Center, WPC. It also tends to take a more regional outlook as well, instead of more smaller based outlook. And also the uncertainty is greater, right? Because the further out in time you are, the little bit more uncertain you are with the forecast. It tends to be largely objective at that point. Now, as we move closer to an event, you can see in the middle there, 2 to 3 days prior roughly to the event, that's very much in the winter storm watch time frame, and we'll talk about what that means in a little bit here. But that is very much a Weather Prediction Center and Weather Forecast Office combined effort in order to make sure that those watches are issued in areas where they need to be. And again, that's more like the state level, if you will. Certainty is a little bit better, but there's still uncertainty there as well. Then as we cascade to the right more, about 1 day prior to an event, that's when we get into the warning and advisory time frame. That is mostly objectively based with some subjective impact information in there as well. We really like to talk about with the public and with emergency managers and whatnot, what those impacts are. And that's very much the Weather Forecast Office space. They're the ones that are going to be conveying that information directly to you. So let's talk about some of those winter hazards now. There's a lot of text on here. We decided to keep this on here because we want to make sure that this is properly conveyed to all of you as you review these slides. We'll start with the dark blue color there. That is an example of a winter storm watch. Those are issued when conditions are favorable. And when we say favorable, in this case, a winter storm watch is greater than 50% confidence for a winter weather event to meet or exceed locally defined criteria or cause severe impacts. So every forecast office has locally defined criteria in the areas which they forecast in. You can see a link in the bottom right there. It says snow criteria map, weather.gov/snow-criteria. That's where you can view what those criteria are for the various areas that the forecast office is forecasting for. So this is issued when, again, conditions are favorable, but confidence is about 50% that a significant winter weather event will meet that criteria. Now, if we move further in time in pink there, you can see there's a winter storm warning. A winter storm warning is when the event is almost imminent. 80% confidence is what we focus on here at the Weather Service to meet or exceed that criteria. So if we're 80% or more confident we're going to meet that criteria, we'll issue a winter storm warning at the WFO level. A little bit less impactful than that, but still significant enough to make sure our partners and the public are aware of is what we call a winter weather advisory. That's the purple color. That is a winter weather event is expected to cause impacts, but will not exceed that warning criteria we talked about earlier, and therefore not warrant necessarily a warning. So there will be impacts, but not quite as severe as, say, a winter storm warning impact would be. Some more examples. In orange there, we have a blizzard warning. Blizzard warnings are issued for sustained or frequent wind gusts greater than 35 miles per hour in visibility less than a quarter mile of snow or blowing snow for greater than or equal to 3 hours. It's very specific criteria that a blizzard warning is issued for. And again, we also, to be a warning, we have to be greater than 80% confidence in that to occur in this particular case. That was a bluish green color. We have lake effect snow warning. Again, it's a warning, so we have to have greater than 80% confidence for lake effect snow to meet or exceed that locally defined criteria we talked about in the previous slide. One thing to note is that lake effect snow warnings are issued for the northeastern United States only. And lastly here, we have ice storm warnings, and that is the purple color there. Again, it's a warning, so 80% confidence that ice accumulation will meet or exceed locally defined ice amount criteria. There is ice criteria for every weather forecast office as well. So let's shift gears a little bit. We'll talk about a different product. We'll talk about winter key messages. The goal of the winter key messages is to galvanize partners, all of you in the media, around a consistent, coordinated message. There's an example of a key message there on the right. It is collaborated amongst WFOs and WPC in order to ensure that consistent message. Primarily, this is used for high impact storms. Not every storm is going to necessarily warrant a key message, but usually the larger storms, the high impact storms, large amounts, large area of impact, of areas that is impacted by the storm. Storms that are expected to cause significant travel disruptions. It could be around a holiday. It could be an early season storm where the impacts might be a little different. Anything that causes a potential hazard to life and property, or a rare event for that matter, is another example. You can see there's bullet points on there to let you all know exactly what to expect here. There's usually an image or two to help convey that. You can see the link there at the bottom. That's the link where these are posted if there was one issued. It's also available on the WPC website, and these are mostly posted to social media as well if there is a active key message. Now we'll talk about the days 4 through 7 winter weather outlook. Again, it's an outlook product, so as we talked about earlier, it's a little bit further out in time than some of those other products we talked about. The goal of this is to support advanced planning of hazardous winter weather for all of you, and also internally for Weather Service as well. It depicts the probability of winter precipitation exceeding a quarter inch of water equivalent over a 24-hour period. So think of it, if you melted down that snow to water, we're talking about a quarter inch or more in this particular case. There are 4 separate graphics of this produced twice a day, showing the forecast for days 4, 5, 6, and 7 from the current time. And you can see the link there at the bottom, one of WPC's pages to link to that directly. And with that, I will throw it to Mike.
All right, thanks, Eric. Another one of our operational national products is the Winter Storm Severity Index. And this has been around for quite some time now, but it was the first forecast impacts index of its kind in the National Weather Service. The primary purpose of this product is to forecast the potential severity of community impacts from winter storms throughout the contiguous United States, and that includes tree damage, property damage, transportation impacts, and just disruptions to your daily life. It is run out 3 days into the future. It includes not only weather forecast elements, but it also includes several non-weather factors, including tree density, population density, and land use. And that's to better hone in on those expected impacts. There are 5 levels of impact provided that you can see in the example on the right. They range from general winter weather to minor, moderate, major, and then extreme impacts in the purple. This product is updated every 2 hours, and the main URL for the website is weather.gov/WSSI. There are quite a few notable upgrades in the product for 2025. This includes updated tree type and land cover data sets. There is also a new wind factor that is now included in the snow load and ice accumulation components to better identify the impacts to trees and infrastructure. Population density and average traffic count information have also been added to identify traffic and highway impacts. There's also been some updates to how blowing snow is calculated. The ground blizzard and blowing snow components have been combined into one blowing snow component, and also now accounts for duration-based impacts. So the longer the blowing snow occurs, the higher the impact will be. Preceding 12-hour precipitation accumulations are also now included in snow amount and ice accumulation, so it won't be cold starting from hour 0. And finally, the flash freeze component has been removed from the product for now. Next slide. So this is a closer look at the components that go into the WSSI. And on the website, you can actually view these components individually or as the combined overall index. So there are 4 main components. The first is the snow amount component, and this just takes into account the actual snow accumulation that is expected. The second is snow load, which shows the potential impacts due to the weight of the snow. You know, will it bring down power lines or tree branches, or will it cause impacts to structures? Ice accumulation shows the potential impacts due to ice and wind on trees and other infrastructure. And finally, blowing snow indicates the potential disruption due to blowing and drifting of snow, again, that is either currently falling or from existing snowpack already on the ground. Next slide. So everything there you just heard me talk about was the deterministic winter storm severity index. So that means those expected impacts are based off our official weather service forecast. But let's say if you want some more nuanced information, like, okay, I know my expected impacts, but what about best case or worst case? How bad can this actually get? Think of something like you're already familiar with our probabilistic snow forecasts. That is where the probabilistic winter storm severity index comes in. So this product depicts the probability of reaching those impact levels that we just talked about. So in this example on the right here, the map is showing the likelihood of reaching minor impacts, highlighting in this case the highest probabilities across North Dakota. So this is designed to be used in tandem with that deterministic version. These higher probabilities of minor indicate where we can expect some impacts due to the winter storm. The WSSIP produces 5 different levels of impact probabilities for snow amount, snow load, ice accumulation, blowing snow, and then the overall impact level. And that's run from days 1 to 7 and is updated 4 times per day. The link for the product is available here on the slide, and it's weather.gov/WSSI-P. Again, there's some main upgrades for 2025, and that includes everything I just talked about in the deterministic version carries over into this probabilistic version. And that's all listed again here for your reference. But it also now incorporates that deterministic WSSI as a member of the ensemble for the first 78 hours of the product. Next slide. Now on this side, you can see the forecast from the WSSIP move out in time. So the images shown depict the likelihood of reaching moderate, major, or extreme impacts. The higher probabilities of moderate that move from the Intermountain West into the Northern Plains show where there's likely to be disruptions to daily life. And the higher probabilities of major or extreme depict where the most severe impacts will occur. And in this example, you can see them move from eastern Montana and into North Dakota as the storm progresses eastward. Next slide. All right, now we're going to switch gears for a second and talk about the snow squall warning. These are brief warnings, again, no longer than 30 to 60 minutes in length, that are issued for short duration, intense bursts of snow and wind that can lead to whiteout visibility and possible flash freezes on roads. You can basically think of these as the winter equivalent of a severe thunderstorm warning. As with all our winter products, improvements with respect to its messaging to decision makers and to the public continues. Most recently, the most recent change to the snow squall warning was the addition of these impact-based warning tags. And these are appended to the bottom of the warning text to provide additional information and context to the warning for our users. The tags are either general, where there will be no tag, or significant, which will display. Additionally, a second tag will display, indicating whether the snow squall is observed and confirmed or indicated by radar. The general warning will be used for snow squall conditions when mitigating actions or societal context will reduce the threat to safe travel. Think if the road's already treated, if there's warmer road temperatures, if it's during light periods of travel, or during the overnight hours. In contrast, that significant tag will be used only when snow squalls pose a substantial threat to safe travel, such that an immediate alert must be sent to all devices in the path. So think of a heavy snow squall producing a flash freeze at rush hour. So in the end result here is that those wireless emergency alerts that you're probably familiar with, otherwise known as WEA, will only activate for those high-end events that have that significant tag. And I'll pass it back to Eric.
Thank you, Mike. Now that we have spoken about the operational products here at the Weather Service, we're going to shift gears and talk about some of the experimental winter products that we have displaying and in the pipeline right now. So we'll start with the Experimental Winter Storm Outlook, or WSO. The goal of this product is to display the probability of realizing hazardous snow and ice accumulations using WFO-specific watch warning criteria as a threshold. So if you recall earlier, we talked about how there are thresholds that every forecast office has when determining if a winter storm warning is warranted. And so this is the probability of reaching that criteria threshold based on an ensemble of various weather models. You can see the link on the right there, wpc.nsf.no.gov/WWD/WSO. This WSO is a 1 to 4 day outlook product. Really, it helps unify the external messaging, and we actually use it for internal collaboration as well between the weather forecast offices and WPC to determine whether or not a winter storm watch may be needed. Again, it uses the event-based heavy snow criteria, which you can see the link there under snowfall criteria there, weather.gov/snow-criteria. So now we'll talk about the experimental probabilistic precipitation portal. This is a website, and you can see the link there at the bottom under it says PPP available here, to view probabilistic snow, ice, and liquid precipitation for the CONUS for the next 72 hours. This past year were 2 major updates, which went into effect at the end of September. First is the addition of probabilistic ice. For the first time, we have probabilities of ice. And also the underlying data set is now using the national blend of models, which is where many of our forecasts originate from. So it kind of brought this product in line with the starting point for much of our forecasts at the Weather Service. There are several different probabilities that are generated, and you can see an example there for Stevens Pass, Washington. You have the expected amount that's there in the middle there, for in this case, 15 inches of snow. That is the official forecast of snow from the National Weather Service. Just another place to view it here on the prop preset portal. You also have the low end amount, which is kind of like, you can think of it as the best case amount. We have a 90% chance of receiving at least, in this case, 10 inches of snow for this particular event. There's also the high end amount, or the worst case scenario. There's about a 10% chance of receiving at least this much snow. And you can see in this case, it's 22 inches of snow. There are also exceedance probabilities. Those probabilities are the chances of receiving at least certain specific amounts of snow at a particular point. And so you can see that in the example here, the probabilities, we always produce probabilities at every point for at least 0.1 inches of snow, 1 inch, 2, 4, 6, 8, 12, and 18 inches of snow. And you can see here that even for 12 inches, in this particular case, it was an 82% chance of receiving at least that much snow. So by doing probabilistic snow information, it provides all of you with a risk threshold. How much risk are you willing to take for a particular event in terms of what the probabilistic outcomes could be and what possibly could or could not happen based on the various weather models. And tying into that, we also have our experimental probabilistic winter web pages. So these are a much local level. These provide customers and partners, all of you, the range of snowfall amounts, but at a more local level. Basically, this year, for the first time, all CONUS locations have a winter web page that you all can go to. And the list of them is in the bottom right link there, weather.gov/prob-snow. You can go there. It'll show you a map, and you just click on your local forecast office location, and it'll take you to their local winter web page. It is the same information as on the Prop Precip portal that I just showed, but it is a more localized level. It shows just that area for snow and ice, and you can see an example there in the image here. You can see that the expected snowfall, the official Weather Service forecast is front and center, and then you have the high end amount, low end amount that we talked about on the right there, and then below that are also the exceedance thresholds, and then it's also a table with specific cities and towns that the forecast office felt was significant listed there with those exceedance tables as well. And again, all of these products are displayed on the local WFO winter web pages. Next, we'll talk about the experimental snow character maps. The goal of this product is to display the consistency of the snow. We all know that the consistency of the snow will matter greatly in terms of the impacts. Is it a dry and fluffy snow, or are we talking about a very heavy, wet snow that's difficult to shovel? And that's, again, to inform all of you about those potential hazards. This year, more WFOs continue to bring these maps online on their local winter web pages. They're right on the local winter web page that I just showed on some of the tabs across the top of the page. I think we're about 20 or 25 or so offices are creating these. We encourage you, if this is something that you'd like to see, to please contact your office and let them know that this is something that helps you make decisions. Something significant about these graphics is that they're also able to be made for Alaska, not just the lower 48 states, but also Alaska as well. The underlying data set can also be accessed through what's called the National Digital Forecast Database, NDFD. That's where all our forecasts are contained and visible. And you can see that link there, digital.weather.gov, and you just have to go to click a little tab that says snow to liquid ratio, and then that information will be displayed. And now I will throw it back to Mike.
Okay, great. Thanks, Eric. We'll turn our attention to the Avalanche Weather Initiative now. So if you've been to any of our webinars in the past or involved with Avalanche-related activities, you may recall that this is all part of an effort to standardize the way that we provide Avalanche weather information to our partners and how we message and disseminate Avalanche watches and warnings from our Avalanche Center partners. So the Avalanche Weather Guidance product is an operational product produced by the offices in yellow on the map in the lower left. This is basically any and all offices that have a stake in avalanche weather or who have partners that request avalanche weather related information. This product provides partners and the public with forecast weather parameters critical to the prediction of avalanche conditions, risk, mitigation, and recovery. In addition to the weather elements, a forecast discussion may also be included to provide any insight into uncertainties in the forecast or to provide more information regarding timing or forecast details. An example of the product can be seen in kind of the center left slide as well. The experimental WFO avalanche weather web pages will also continue for this upcoming season. These sites are critical sources of information for partners and the public to easily obtain avalanche products and information, and having a standardized experience for all users helps to increase the visibility and accessibility of information as well. The web page includes Weather Service weather alerts, Avalanche Center avalanche alerts, clickable points or polygons for forecast information, relevant weather discussions, a precipitation summary table, tabular and graphical forecasts, and a local content section. One of the newer features is also an optional probabilistic display that complements the deterministic forecasts to provide more context for our decision makers. Those websites are linked off the landing page shown on the slide here of weather.gov/WRH/avalanche weather. And as a reminder, if you are an Avalanche partner, please work with your local weather forecast office for more information or to set up forecast areas or configure the websites. Next slide. All right, next we're going to briefly discuss some of our safety and outreach material. Next slide. So like in previous years, there are numerous resources available for safety awareness and outreach. This includes content on winter hazards, including infographics, social media plans, presentations, and videos. We encourage all of you to use and share this information as needed. This will all be on the first website listed here on the slide. The second link there is our general winter safety page, where you can find all kinds of safety information for hazards from nor'easters to ice storms to snow squalls to extreme cold and everything in between. The Weather Service also participates in the NOAA Great Outdoors campaign. So this focuses on weather safety while recreating outdoors. So in the winter section, we discuss hazards like extreme cold and exposure, avalanche danger, winter storms, and ice safety. And this also includes fundamental actions to take, if you're faced with some of these situations, as well as safety content for sharing. That's available on the third link on the slide there. The graphics shown below on the slide are just a few examples of some of those safety graphics that are available for your use. Next slide. In addition to that safety information, there have also been several efforts done in the past years to increase public outreach and available information on some of our products. So the first link on the slide has resources for a better understanding our probabilistic winter forecasts. So if you click on that link, it will take you to a page that hosts a fact sheet and an informational video, as well as the probabilistic precipitation portal and an access map to all of the probabilistic snowfall winter pages. The second link on the slide is the snow squall impact-based warning tag fact sheet. And the next two links will then take you to both the WSSI and the WSSIP pages. And on those pages, near the bottom of the maps, there are some outreach and training materials. So you have a better understanding of how to use and apply those products. And for now, I'll pass it back to Eric to wrap us up.
Thank you, Mike. Just to conclude today's Winter Partners webinar, here's some contact information for myself, for Mike, and for John on the left. Much of the links that we spoke about today are just in one easy to find location here on the right. And again, these slides will be provided to all of you at the conclusion of this. Again, they'll be posted to the Weather Ready Nation calendar. This video will be emailed to all of you. Also, this will be posted to the Weather Ready Nation calendar as well. And we encourage all of you to please, share this video broadly to anyone that maybe couldn't make it or you think might benefit from knowing this information. We hope to return to you next year in the live format, but we're glad that we were able to record this year for all of you. Thank you very much for watching, and we will see you later. Take care.